Hello, everyone, and thank you for joining our Modern Application Development webinar series. Today, we'll be talking about simplifying container adoption with the managed Amazon EKS environment. My name is Curtis Reese. I'm a Senior Solutions Architect with AWS focused on containers and app modernization. And today, I am joined by our AWS Premier Tier partner, Rackspace. And I've got two wonderful principal architects here. I'll let them introduce themselves.
Great, thanks Curtis. Hello everyone. So Sriram Rajan, I work in the Rackspace Managed Public Cloud team. My current role is about building offerings for customers, focused largely about modernized technologies like containers, and my background has been in IT for about 15 plus years. Tari, over to you.
Okay. Hi guys, my name is Atari. I am a principal architect at Rackspace. I'm in the professional services department. My focus is on application transformation, transforming application architectures to be more cloudy and transforming the delivery of applications, so more of the DevOps space. Have a 15 plus background of experience in application development, solution architecture, etc.
Awesome. Thank you both for joining us today and sharing the capabilities of Rackspace with our customers. Before we dive into the modernization story and what we can do with containers, let's talk a little bit about the symptoms of the legacy development culture and some of the challenges that customers are faced with today. And so when we look at legacy application development, we think more of in the terms of, say, like monolithic applications and waterfall project management cycles, where there's these longer release cycles where it takes multiple developers working on multiple features to create the built application over a longer period of time. And one of the challenges there is it takes much longer for these releases and features to see the light of day. And along the way, because it's such a long cycle, operational challenges that come into place and recurring bugs that we see that are discovered either through testing or through our users, it takes a much longer time to find these and address them effectively. And oftentimes it can take multiple releases to be able to address all of them. And so what this equates to is over time, it creates what we call technical debt, and it degrades the quality of the software and makes it worse potentially over time. So why is this a problem? Well, the idea is that we want our customers to be able to identify the needs of their customers very quickly and capitalize on the opportunities that they're presenting so that they can react to those opportunities far more quickly in a much more agile way. We want them to be able to address those needs and be able to stay competitive in a faster clip so that they can adjust more rapidly and be more successful and competitive in their field. So why is this now essentially a challenge? Well, with cloud being the new normal, a lot of companies are finding themselves in a position to be far more global in scale and digital in nature. So with the pervasiveness of mobile phones and apps on phones and the web being basically everywhere on every device, 47% of CEOs are seeing the need and then the pressure from their board of directors to push their business to be far more digital. And 79% of CIOs believe that it allows them to prepare for those changes and be more agile in their delivery of changes and features for their customers in a much faster manner. And 60% of all business leaders are seeing it as a means and capability around remaining competitive. So what are the goals of modernizing a development practice? We've kind of hit on these a little bit, but I'll dive into them a little bit more detail. Is we want to shorten the cycles from idea to production. So we want to basically identify what the needs of the customer are, get that in front of the developers, get it into through testing, and get it through the ideation and delivery cycle out to production as fast as possible. But we also want to do that in a way that is as safe as possible. So we want to automate as much of these processes as can be. And if we think of this in the sense of a traditional application where there's literally an operations manager sitting in front of the deployment scripts with their eyes on glass as they're trying to do these deployments, oftentimes that's not necessary and it's a slower process. We want to be able to automate as much of the entire delivery process as possible. So we only involve people when they actually have to be involved. They're not just monitoring. And we basically want to make a flywheel of this. So we want to continuously improve this system, identify these ideas as fast as possible, get them developed and out to production as fast as possible, and over time improve our overall business processes along the way so that the team, the product, everything is a well-oiled machine and is humming. Now, you've heard me talk about modernization a couple times. I'm going to pass it over to Sri so he can actually define this in more greater detail.
Thank you, Curtis. So the term modernization is relatively loose in some sense because it might mean different things depending on your perspective, depending on your current state in terms of how your applications are working today. But Gartner tries to define this. I mean, the term migration of legacy to new application platforms is one good way of looking at it. You also hear the terms re-architecting or re-platforming as part of sort of shifting from an old legacy model to a new one. And some of the more technical terms are cloud native, microservices, serverless. I think bogging down into the definition of application modernization is not very useful. It's more, it's better to focus on the outcomes that we want to achieve. And let's look at that from that perspective, because if you look at from that, it will be much more clearer where the modernization needs to happen and how does the business get value from that modernization. So one of the reasons to look at modern architectures is the idea that you have to start separating concerns. So traditionally, applications were more monolithic, where they were very tightly coupled, several development teams coming together to produce one sort of business application. And that slowed things down. A change in a component required much more testing across all the interfaces, which meant release cycles were often delayed. So one of the ideas with things like microservices or modernization is to sort of figure out a development pattern where the concerns are separated into smaller groups or smaller teams. And then that team is then empowered to sort of make decisions for their own technology, for their own changes. And they're not generally worried about the sort of the blast radius in terms of how this impacts other parts of the system. This becomes very powerful because now certain teams can move at a faster rate, and you can also trial certain things if that particular team wants without having to get consensus across everything. The other idea around modernization is the concept of shifting left. Curtis touched on this a little bit in the previous slide, but this is a term that IBM coined in the late 90s, but it makes a lot of sense in the more modernized, automated world of today also, in the sense that the more you shift left, your problems, your bugs from, say, production environment to dev, the cheaper it is to fix, right? So a bug or a security issue that you find in production is going to be much more costlier to fix than in dev. So that's the principle. Now, where modernized systems take that principle is they take it to automation and say, okay, how do I build systems that allow me to do that, right? How do I build automation into my whole pipeline from development to production, such that all these things are automated to the highest degree possible so that I can start finding these things early on. And this led into the separate teams as well. The teams now are more assured that an automated system that's helping find issues before, and so they are more likely to take more changes done, more features pushed off. And the third bit that kind of finishes this off is ultimately all these things need to deliver value to the business. And that's what modernization ultimately should aim, is to say, how am I delivering value to customers faster? And how do I embrace technologies in such a way that my customers are seeing value at a much faster rate? And you can also look at this collectively as saying, take all this and remove obstacles that are basically hindering progress in your current world. So that's a bit of the why or the reasons to modernize. Now let's jump into a bit more technical stuff into, okay, how do I now take some of that principles of automation, of modernization, and see how containers sort of lend themselves to better modernized technologies. So let's start looking at containers as a concept, right? So the container is relatively new in terms of adoption, but it's been there for a while. The idea with containers is you sort of package everything together in one sort of image, if you will. Typically, if it's Docker, you're talking like Docker images, and then that image effectively runs similarly elsewhere. So if you look at the benefits of that sort of technology, they're modular. By nature, they are very, sorry, let me start again. By nature, they force modularity in design, in the sense that when you're thinking of deploying applications with containers, you automatically start building smaller modular components, because containers in many ways force that. And this lends into sort of that separation concerns model as well, where we can think of different teams running their own set of container images and then together forming the larger application. Containers are also portable. They can easily be moved across environments with almost no change, and they'll work consistently in those environments as well. So they run the same, whether they're running in a developer's workstation or in production. Yes, there might be some subtle differences in terms of, say, workloads or performance and things like that between environments, but to a large degree, they are consistent across all the environments. And then the last bit, which lends heavily towards automation, is the efficiency. So while containers are generally more efficient in terms of using hardware, I feel that the true power from containers comes from the fact that they're very fast to deploy. They're very fast to change. So traditionally, virtual machines would start up in like minutes. You're talking now seconds. And that, again, helps towards those outcomes where now you can test some of these changes faster, roll back if it's needed, build new environments, tear them down, and do all kinds of testing in a more efficient manner, which then allows developers to make more changes during the process. Now let's go a level further. So we've looked at some of the benefits that containers bring. Now let's look at putting containers into sort of a modernized system with all the building blocks and components of it. Now this slide is quite detailed, but what I would like to say is often with customers that we have seen, this may seem daunting on day one, but really it's more a modular approach. If you have sort of the framework built in and you have some stuff incorporated, it just gets easier over time. The idea is to get a framework in place that sort of lends towards modernized systems and then slowly iterate and improve upon it. So in this visualization, everything starts with humans. We haven't managed to find a way to get rid of humans from the equation, but heavily involved with humans is the concept of robots or automation in this case, which should be core way of operating. You need to start thinking about how do I reduce the task that a human has to do, and how do I bring more and more automation into the activities that I'm performing, and leave the humans just to do the stuff that they are more capable of doing and they're required to do. And then you have sort of the two pillars, right? The application and the infrastructure. Some might talk about security being a pillar. I personally think security just should be ingrained into each of these and not sit as a separate sort of pillar. It should be ingrained in both the way you do application as well as infrastructure. From an application perspective, you need a source control repository. This is not new. Git, SVN, CVS, technologies like these have existed for a while, and developers have generally relied on these things for collaboration, for exchanging code. So that element more or less stays the same. But you start introducing a continuous integration framework or system, if you will. The job of this would be to start doing all the testing that's required. It could start as simple as unit tests. It could be smoke tests across the application. It could be more complex integration tests. But the idea is every change that a developer makes to the source control gets tested through a continuous integration process or a CI process. And that, the more you automate that, the more faster your changes become. And that system may start with a few rules on day one, and over time you may start realizing, okay, I can automate all these things as well. And of course, there are always going to be certain elements that require some human touch. So for example, the CI system could say, okay, I've finished all my automation tests. I would like a human to do a code review, for example, or a QA to do some testing of a user interface. In the container world, the CI system eventually creates container images. So the developer pushes code to a repository, the CI does all the testing and builds a container image, a Docker image, if you will, and then stores them in a repository. If you now shift to the other side, now you start applying the same principles that you've always done with application to infrastructure. You talk about orchestration when you talk about provisioning infrastructure. You talk about code provisioning that infrastructure. You talk about that code living in a source control system like Git. So instead of manually provisioning this or a user clicking through a control panel, you're now saying, I'm going to template my infrastructure using tools like CloudFormation, for example, and then build that. This feeds into the continuous integration system because often the CI system will require to spin up new environments to test and tear them down. So the orchestration sort of lends into the testing element as well. The orchestration then provides the environment. So this could be your dev stage, production sort of framework. They will generally inherit configuration. So the intent here is to keep orchestration as agnostic to the environment as possible. So the same set of orchestration templates are used to deploy all sorts of environments, whether it's dev, production, or staging. But each environment then inherits certain configuration items, maybe the size of instances, maybe the number of instances, maybe database types, and other things, such a way that the orchestration can then sort of use that to customize these environments as needed. The separation of these two also allows you to start provisioning more environments just by a simple change to the configuration. So if you decide to do like a testing environment for penetration testing, you can spin that up fairly easily. To complete the puzzle, the container images then leverage a continuous deployment system. That the job of that is just get all these images and then have them deployed on the different environments. So the continuous deployment system's job is primarily how do I push all the changes to my environments, and also how do I push them in a way that I limit downtime as well, right? So things like rolling updates and so forth. And then the last piece of the puzzle, this is more the operational side of things, but equally important. You have everything working from dev to production. You still need to run this from an operational perspective. So you still need to understand how the environments are performing. So you need performance metrics. You need logs for troubleshooting if there are issues. You need logs for security audit purposes as well. And then also you can use an analytics system that can then sort of help take all these metrics that you're collecting and help drive automation. And this system sort of feeds into, again, humans and robots. You can define automated activities where in response to an alert, a robot takes action, and then if it still doesn't resolve the alert, then a human is paged, for example. So this slide, like I said, a lot of building blocks to it, but the idea is that the framework needs to be put in place, and then over time we start improving on each of these things. Now let's take a jump ahead and say, okay, let's take this sort of visualization, and let's say, how does AWS containers and sort of Kubernetes help with that? So you still have the same building blocks; those don't change. As you saw in the previous one, there's a lot of different components. But what AWS and Kubernetes and containers do is sort of provide a lot of these functionality through services and products, which make your job of building sort of a framework or a system like this easier. So starting with source code system, you have AWS's code commit. This is a source, it's similar to Git. It has integration to Git. It provides a lot of features and integration to the AWS ecosystem. So it's pretty easy to plug in if you're already familiar with sort of a Git style repository. From a continuous integration perspective, AWS Code Pipeline can provide a lot of bells and whistles, a lot of features to help sort of build that pipeline. See, there are several things built into it that you can do. You can also integrate that into things like AWS Code Build, which can be used to sort of package and build your code. And then also, if you're using open source technologies like Jenkins, they can all sort of come together to complete that continuous integration puzzle. You can also use just one of these, depending on how you do it. The idea here is eventually, from what we've seen with customers and others, there's always going to be a mix of different requirements. Ultimately, you pick the best tool that satisfies your requirements. The CI system then splits into the container registry, and this is the Elastic Container Registry from Amazon that can be used to store all the Docker images. You can sort of version it, tag it, and this is quite secure access as well, so you can keep it sort of limited within your VPC and access these images in a fairly secure and easy manner. And then switching to the infrastructure side, there are two elements that come together to sort of finish that infrastructure orchestration puzzle. So first is AWS CloudFormation. CloudFormation can be used to pretty much provision the entire infrastructure. So starting from your VPCs to the networks to the respective, say, EC2 instances, EKS clusters, whatnot, everything can be templated through a CloudFormation template and deployed. And then Kubernetes sort of picks up from there. So there are other bits of orchestration that go into the application side. For example, running X copies of an application, or pods, if you will, that gets then handled by Kubernetes. And so you can sort of combine a CloudFormation template to provision the infrastructure and a Kubernetes manifest to deploy the application. Of course, this is again stored in a source code repository, which would be very similar to the previous one. So Code Commit is a great service product that you can use. From a configuration standpoint, Kubernetes again provides a lot of internal constructs to sort of store configurations. So you could get the concept of namespaces, for example. You have labels, variables, configuration store. But if you need something external, you also have AWS's parameter store. So you can sort of mirror the two, marry the two together to make it work as one coherent system. And the same thing happens on the deployment side as well. So ultimately, once you package a container image, Kubernetes sort of then becomes your deployment tool. And it can then be used to sort of do the deployments for you. You can push the images across these environments, do sort of rolling updates and so forth. And a glue that's great addition in AWS world is Lambda. So while Kubernetes can do a lot of these things to complete the deployment, you often need external triggers to complete that. So you can configure Lambda in such a way that maybe a new image lands in the registry, Lambda then triggers Kubernetes to the deployment. So again, this is a case where tools like Lambda sort of help complete that automation stream, right? By just adding some additional automation that finishes the whole end-to-end automation. From an environment perspective, you have Elastic Container Service for Kubernetes, or EKS, which basically does all the undifferentiated heavy lifting in terms of provisioning the Kubernetes master nodes, the controllers behind it. Everything all is provisioned by EKS for you, and you have a fully working and conformant Kubernetes cluster that you can then use. As you go into some of the modernized ways of running containers, and you are interested in things like an application mesh or a service mesh, AWS App Mesh fulfills that need, where you can sort of leverage that product and service to provide a service mesh for your applications. From the perspective of operations and analytics, so you have Amazon CloudWatch, which provides CloudWatch logs, CloudWatch metrics. They all are part of the CloudWatch suite of products, so you can integrate that into your container deployments, get logs from it. You can get metrics from the worker nodes or the EC2 instances underneath it. You can get metrics from the load balancers and so forth. And then if you're looking at analytics, Amazon Elasticsearch can be plugged in. So CloudWatch easily feeds information into to Elasticsearch, which can then be used to visualize and run reports on. And of course, all this can be tied into sort of a notification service using the SNS or simple notification service to both the humans and robots. Robots in this world would be things like Lambda. You can also think of it in terms of containers themselves doing some of these automation, but Lambda can again provide the glue to complete some of these things. So again, an alert happens, Lambda can trigger a redeployment of the container and then see if that fixes the problem. And if it doesn't, then sort of page a human to work on it. So this view is layering some of the technologies from what we discussed before. So as you can see, a lot of these things are available from an end user perspective in terms of technologies. It's a matter of making that all work to your specific requirements, to your specific workflows. So let's jump into the next bit. So let's talk a little bit about how sort of Rackspace approaches, right? So we have looked at some of the technical bits on how we put this together, but let's now look at how we help customers sort of in this container journey. And let me hand over at this point to Atari to talk about the first bit, and then I'll pick it up from there. Atari, over to you.
Okay, thank you, Sri. All right, I'm going to talk to you guys about how Rackspace helps customers undergo this container transformation journey. And then once I'm done with that, I'll give you an example of how we help the customer transform their current application ecosystem into a container platform on AWS. So the approach that we normally take is the first thing is we validate the customer's container modernization strategy. You know, we go on site, we talk with the customer, we assess their applications, and look at the things that we can do to containerize that application. For example, a lot of customers do have monolithic architectures, and one of the things we do is we help them rationalize and break up those monoliths into the small reusable chunks that can be deployed and managed separately, right? So that's one of the first things that we do as part of that journey. At the same time, we also educate the customers on container solutions because a lot of our customers have various degrees of expertise. There are some customers that are very familiar with, for example, technologies like Kubernetes, and some customers are not that versed in that. So we go in there to explain how it all works, you know, give them pointers, just get them more comfortable with how containers work. The next thing we do is we come up with an architecture, right? So once we've figured out the strategy, we've educated them on containers, assessed their application architectures, we actually say, okay, how is this application architecture going to map to a container-based architecture? This is where we do things like build out the Kubernetes EKS platform. You know, how do we construct the worker nodes for high availability? How do we set up security groups? How do we set up networking? We look at all of those things, right? The next thing that we do is we also build out the delivery pipeline. So it's one thing to build out the container platform for the customer. The next thing is to help them build out a CI/CD pipeline using the tools like code commit, code pipeline, and the Kubernetes API to actually deploy these applications. So ultimately, this is the flow that we follow. We figure out the application modernization strategy. We educate them on the platforms. We design their application architecture as well as the Kubernetes platform architecture, and then we help them design their CI/CD pipeline. Once that's done, we then hand that over to our managed services side of the house, where they can keep the lights on. Sri, you want to talk more about what we do from the operational aspect?
Sure, thanks, Atari. Yeah. So if you think about the first block of services, right? So these are more getting stuff up, getting an application modernized, getting the right framework in place that we talked about in the slides before. The second bit is about how do I now keep that functioning properly on an ongoing basis. Your solution is maybe largely driven by containers, but there's a lot of elements around it. You start to manage the infrastructure around it, and that comes in managing security, for example, managing cost, managing performance. All those aspects of infrastructure management is part of our sort of managed offering, if you will. In that world, we help make sure that all the infrastructure up to the Kubernetes level is working and functioning properly, and any other components, right? Again, you may be running EKS, but you may also having databases, for example, Aurora on the other side. You may having Dynamo. It's helping with all that entire solution and then making sure all those things are managed properly. And specifically to the containers or to Kubernetes, we also offer sort of Kubernetes services or managed Kubernetes services where we go into more deeper into the Kubernetes layer. We have teams that are more trained in Kubernetes or certified in sort of the Kubernetes certifications and helping you build, for example, the manifest properly, configure these in the right manner, and also just general advice, and also just management of those components, things like plugins and all those things. The Kubernetes ecosystem is quite evolving fast, so it's also about finding the right tool for the right problem. And again, these engineers have exposure to these things and can help you advise and do that. And then the last thing is sort of security services. So Rackspace has a managed security offering. For a while, it extends into containers as well. The idea with this is to figure out how do we apply the right security principles to the infrastructure, how do you get metrics and data from it, and then sort of feed that into tooling that can then look at patterns and detect anomalous behaviors. And then we have a team of experts who are then trained to sort of respond when these things happen on your behalf. Of course, this is the entire adoption path from end to end. What we have seen with customers is they may be in different stages of their journey, if you will, right? So they've already done some of the modernization internally. They are now up to speed with sort of the technologies, but they just need helping with the delivery pipeline and the operation side. That's fine as well. The idea that these are in the blocks is you can sort of consume them in the way that you want. And the other way to look at this as well is you yourselves can think about your own adoption path along the same lines and say, how do I address these things? And then if you need a partner like Rackspace to help some of that, then we can do that as well. Now let's jump into sort of examples or customer solutions and talk about some specifics in terms of the lessons you have learned with this. I'll pass it over to Atari to talk about the customer first.
All right, thanks, Sri. So yeah, I'm going to talk about Total Tracks. They were a customer that came to us and they wanted to modernize their application. The reason they wanted to do that was they wanted to scale. They wanted to scale efficiently, and they wanted to minimize scaling costs. So essentially, what they came to us, and they told us what they were trying to accomplish, right? So we went on site, we looked at their application. So let me give you a little bit of background on what they do. TotalTracks, they have an application that they can manage fork truck data within data warehouses. So they have devices that you can attach to the fork trucks. The fork trucks pass telemetry data back to the application, and clients can actually look at that application and see how efficient they're managing and moving packages around in their data center. So the problem was, if they want to onboard a client, it took a lot of manual effort. It took about 3 days to onboard a full client. On average, they were onboarding about 5 clients a month, and they were looking to scale that, where they were going to onboard hundreds of clients a month. And the current process and mechanism wasn't going to work. So we went on site and we looked at their application and we looked at how it was designed. And immediately we were able to identify that containers could actually help solve this. So we helped them brainstorm an application architecture on how to package, on how to deploy, on how to reconfigure their applications in a supportable manner for containers. So once we did that and we did the design for them, the next thing that we did was we figured out, okay, we need a container orchestration platform for them to deploy their applications. At the time we did this, EKS was in preview, so we actually used AWS's other container orchestration platform at the time, which was ECS, and we're able to build that solution for the customer, and we're able to build and deploy their applications. We were able to get the deployment times from 3 days to actual 5 minutes. And part of those 5 minutes, we had 2 minutes that were part of wait times, essentially, right? Because we had to, there were some race conditions and we want to make sure everything was good. But it was a real game changer for the customer. They could build their applications automatically. They could click a button and they could provision that instance of that application for a customer almost instantaneously. That included setting up the databases on the back end that the containers had to talk in. So we were able to set up RDS for them and configure the databases there. We were able to set up RabbitMQ for them. We were able to set up DNS entries as well. And so this was something that the customer really, really valued. It transformed their business. And right now we're in talks with them to re-platform the ECS cluster to EKS, moving forward. So this was a really good use case. The impact was very drastic, and this was one that they were very happy with Rackspace. And
thanks, Tari. So on the other side, I want to share a bit more from our experiences with running these environments, EKS environments with customers. Talk about specific customer use cases, but I want to try to sort of whittle down to sort of 3 areas that you could think of it as takeaways in terms of operating EKS efficiently, right? So this is stuff that we've learned in helping customers operate and build solutions on top of EKS. The first thing I would like to call out, something to think about if you're designing solutions in EKS, is to think about designing for the availability zones. There are certain features of Kubernetes that if you want to leverage it, you have to think about sort of defining your availability zones and the worker nodes as part of that differently. For example, if you plan to use elastic block storage within your Kubernetes pods and deployments, the block storage is limited to an availability zones. So your node groups now have to be architected for each availability zone. So these are simple things and often easier to fix upfront than maybe later on. So that's one thing to think about. And the other thing with auto scaling is just leverage the cluster autoscaler. So cluster autoscaler is a Kubernetes add-on, with AWS contributing to that as well. And that sort of integrates Kubernetes with the AWS ecosystem in such a way that the autoscaling is much smoother. So that's something to think about, availability zones and then leveraging the cluster autoscaler. From a load balancing perspective, we have quite a few options. AWS provides you the classic load balancer, the application, and then the networking load balancer. Our from my perspective as well, and from what we've seen with customers, is to avoid the classic for most part, unless you have a very specific use case where it fits. Leverage the application with a load balancer, which is usually a better fit for sort of a microservices world. And then also design sort of your applications in your Kubernetes manifest on using ingress controllers. So there's an application load balancer, ingress controller, or ALB ingress controller, which can be used to sort of tie in your Kubernetes deployment with the associated load balancers on the AWS side. And the last thing, and this really applies to any container solution, is to review end-to-end monitoring. Containers come with an inherent challenge because they're transient. You may be doing several deployments. Your short-lived containers, they may get killed and restarted by Kubernetes as well, depending on all kinds of changes in the environment. So you need to have end-to-end monitoring such a way that all the monitoring data is extracted from that platform and stored centrally. That way, if something goes wrong, it's easier to pinpoint or search for issues. And so to think about end-to-end monitoring from the perspective of from the VPC down to the application, make sure all these things are monitored properly. CloudWatch does a lot of these things. There's also Container Insights, which is now in preview from AWS perspective, which helps getting some of these monitoring and logging into a centralized location like CloudWatch logs, and then can be used to sort of do other automation on top of it. So with that, I would like to thank everyone for joining us. Hopefully this information that we shared towards modernization was useful for you. If you're interested, hit us up and we can discuss more for your specific needs and help you build a solution that fits your requirements.
Awesome. Thank you, Sri and Atari. Really appreciate you joining us today, and thank you, the listeners and viewers. So thank you for joining us as well. We appreciate you spending time learning about our capabilities and what we can do to help you modernize your applications and be successful with containers. So thank you all.